Well, join me, if you will, on this very fun adventure that is about to unfold before our very eyes. This is a U2000, and somebody has done some wonders to this. Now, I say that because of the condition that it's in. So, this is on the heels of the one in the previous video, I should say. This is the second one of these that's owned by the same person that sent it in for repair. They sent in a flatback if needed, along with the cap kit and some various other parts. We may need them, we may not. Definitely going to recap it because the caps that are on here are replaced, but they're a hodgepodge of different vendors and styles and things. So we actually are going to redo the cap kit, but this thing is yeah. We'll start off with, you know what, let's just remove the remote harness here and the remote board, and all the pots are in good shape. I checked all those already, so we'll get that out of the way. And the neck board, we will remove that as well. And there we go. Now it's actually in pretty good condition. Nothing's like flat over, touching, or bent or loose. These are all somewhat secure. We'll have to reflow all that stuff as well, but we'll set that aside. But the main board here, the problem that plagues these U2000s is that the heatsink gets like super hot. Like you touch it for a second, it burns your finger hot. And the problem with that is that the H coil is right next to it like this, and it gets so hot that the plastic will break. You try and adjust it and it just cracks. And if we look close enough, you can see how discolored it is in the middle here, how it's heat soaked, and in the middle here is very discolored because of the heat, and the plastic has gone, you can see the plastic here is discolored as well from the heat, and it just cracks it right off. So what's interesting though is that I mentioned in the previous video that there's different versions of the U2000. There's different revisions. And some of the revisions are like lukewarm at best. You can hold your finger on there all day and it's barely even hot. And then other revisions where if you hold your finger, that'll burn it within a second. You'll have to go to the hospital type of thing. So I don't know why some of them are scalding hot and the other ones are lukewarm. I've done as much as I can troubleshooting wise to figure out what's different in components and things, and nothing that I can tell is different. So I don't understand how some are hot and some aren't. I thought it might have been a flyback problem. I swapped flybacks on a set and it didn't change the heat thing. So I've done everything I can think of and nothing solves the problem. But that's outside the scope of the video. We're just going to concentrate on getting this up and running for now. Maybe I'll try and do the research in that later. But somebody has replaced U701 and put it in a socket trying to troubleshoot stuff. They have replaced R303, which means they probably had a vertical collapse problem they were chasing. R728, I've never seen this burned up this badly. You can see both sides of the pads here are burned up. This one's less burned up because there's a giant trace to dissipate the heat, but this one here is burned, so I don't know if this resistor is bad or if it's the wrong wattage. I don't know. I'll just replace it to be sure. Looks like someone's replaced Q703. They've done a hodgepodge cap kit, and that's kind of the extent of things on the top. Now the bottom, here comes the fun part. So R104 here, our ceramic resistor, you can see here that right here, it's wobbling. So someone's pushed down on that and popped the pad off, but it's still connected to the tray, so I don't think it's an actual problem, but we'll have to see if we can get that fixed. And then, of course, I mentioned how R728 here is all burned up, and somebody has put this little jumper on here because of how burned up the pad was. It should not be like that. There's nothing that should cause that. So I don't know if it's the wrong wattage resistor or not. Somebody has removed the W159 jumper to try and 156, sorry, 156, to try and do the light bulb test, and they didn't really solder it back in very well. The vertical IC, every pad is lifted. Can I get closer here? Nope, not really. Every one of the vertical IC pins are lifted. and even pins that aren't part of the IC are lifted, or pads I should say. So all the pads on the vertical IC are lifted. That's nice. And then we get to kind of the coup de grace here, the flyback. Let's grab this here. Okay, let's see if we can kind of zoom in here. That's about all we get. So this is lifted. This is lifted. This one here is lifted. And then this one here is broken off completely. If we look right here, this one here is broken off completely. Completely broken. So I don't know if that got knocked or what, but this is broken off completely. So that doesn't even have a connection to anything. And that one's lifted and that one's lifted, and they're all, see how the whole thing is, I don't know if somebody banged this and smashed it, or if they just, some knucklehead tried to take this out and put it back in their troubleshooting, and they put a wire around that pin there, and I don't know, but that's pretty bad. So we're gonna have to tackle this kind of like one thing at a time here. It doesn't appear that HOT has ever been replaced. There's no rework on those joints. Yeah, so I think Q703, that's not too bad. All right. Well, I think what we'll do first, before we really do anything, is we'll check R104, we'll fix that pad, and then we will do our light bulb test and verify our power supply is okay. If it is, then we can proceed with redoing the flyback, trying to fix the pads over here for the vertical IC, testing various components, and seeing what's going on, because someone has replaced R303 probably in an attempt to try and figure out a vertical collapse issue. I think they probably replaced the vertical IC also. And then we'll have to figure out what's going on here with R728, because it should not get that hot to do that, burn those pads. But all right, so I guess first things first is let's turn the iron on and see if, well, both pads on R104 are lifted. Let's take another look here. Both of the R1, there's one pad there, lifted and moving. And then this other one here is severe. But it's still in circuit, so it's not like it's causing a problem, but obviously shouldn't be that way. Let's go ahead and just verify that it's within spec. Should be between, it's a 10K ohm resistor, but it reads between 10 to 13 in circuit. So as long as it's between 10 and 13, it should work. And we're at 15K. That's pretty high. I mean, it may function at 15K, but it's a 10K resistor. It's rated at 10K. 15K, it's out of tolerance technically. So I think I should replace it. I have replacements here. I think that one of these reads, I think one of these reads too high. I got a couple of OEM originals here. OEM original, is that redundant? I think that's a bit redundant, but this one is, see, that's 14, and this one is, that's 15 also. So I'm not sure why I'm saving these, but if you look here, they're supposed to be 10K. So, I mean, technically I think these are out of tolerance as well. So I've got some replacements. I think I'll toss one of these in there. Another, this is a direct replacement, 10K 10 watt, and I think these are 7 watts. So if anything, this is probably a bit better. So I think I'll toss one of this thing in there because it shouldn't be that out of tolerance. So I think I'll put one of these in there. Let's do that real quick. All right, set that. Let's see what it reads out of circuit here once we get this other one replaced, or this other one installed. Turn my fan on here. All right, now what I want to do is see if I can glue these pads back down. As soon as I find my... Wherever the hell my glue went, where'd it go? You guys tried to hide it from me, but I found it. So we're going to lift these up here and put a little glue underneath them. If I can. Alright, I'm just going to tab a little glue under here. We're going to try. Come on, you. What's going on here? What the heck? Oh, there we go. All right. A little dab will do you. You don't need to get a lot. Okay, now push that down. Clean this off. Now we can put the new resistor in. And solder it in place. There we go. Now what we need to do is push down on this so these pads sit flush. There we go. And that should solve that problem. Okay, so I think that'll work. You want to add a little bit more here. And a little bit more there. Alright. I think that'll work. They are sitting nice and flat now. And let's make sure that we don't have any... Yeah. I think that'll work. And we're not sitting directly on the board. And we're not touching any other components. I think that'll work. So now if we check this one, it should be 10K. $10.05. All right. Now what does this other one out of circuit? Is it still 15K? Yeah, 15.39. So I'm going to say this one's probably not good because it's way out of tolerance there. I don't know if 15K is out of tolerance of 10K. I got to look up the specifics of it, but I don't know what the actual tolerance is of this resistor. But having it be, you know, 500 ohms out of tolerance there. Is that 500? Yeah, 10,000 plus 500. No, I don't know. That's right, isn't it? No, that'd be 10,500. 5,000. 5,000K. I'm sure everyone's like, what the hell? This guy's a moron. I'm sorry. It's right now it's 8:35 in the morning, so I know that's always my excuse, but that's the excuse that I'm sticking with. At what time of the day will I know the answer? If it's too early now. Yeah, it's 5,000K out of tolerance, and it's, you know, 10,000. It's a 10,000 ohm resistor, and it's reading 15,000. Yeah, that's 50% out of tolerance. But anyway, okay. Now that that's done, let's go ahead and lift out W156 here. And oh, I was looking at the wrong one. This that's for that other resistor there. Let's get W156 out of here. That bad solder joint was actually off that burned up resistor. Alright, so that is out. Let's grab our lead and clip onto it. Grab our light bulb. Grab our power. Plug it in, plug it in. And in theory, let's turn the fan off so we can hear if it makes a chirp. It should do a little quick chirp, and then if assuming it works, then we can see if the light bulb lights up here. Okay, so 1, 2, oh, get that off of there. 1, 2, 3. I heard a little bit of a chirp. There's that noise. Now here we go. All right, a functioning power supply. Oh, gosh darn it. Slip off there all the time. All right, so there we go. It does work. Okay, let's turn it off and let's discharge it. So now the fun begins. We have to repair the flyback pins. We have to fix or figure out what's going on with this resistor that's burning up the pads. And then kind of go from there. I think we'll start with the resistor and save the flyback rework for last, because that's going to be the most fun thing. Okay, that jumper is reinstalled. I gotta turn my fan back on again. Now let's get this resistor out of here. I can't get that out of there. There we go. Alright, let's see what this reads. And I'll have to use the other one we just fixed as a reference here. Alright, so this resistor reads 1K. Is that what it's supposed to be? Let's use our other one that we just fixed as a reference, because it's already been replaced. And this one reads 1K, yeah. So 1K appears to be the rating. So it's the right rating, but I don't know what would cause it to burn up like that. Let's see if they have that in the parts here. No, I don't see anything in here. There's a 702 and a 701, a B plus pot, and HOTs. So that means we're digging into the spare parts closet here. And it looks like I have one right here. This is a 7400, but I can still use the resistor off of it. I think it's this one. So let's measure this one. And we get 1K. All right, let's put this one in there. Okay, here, let's clean up, put some of this stuff away here. We gotta clean up these pads a bit. Let's get rid of this piece of wire and do this a bit better. I think that'll be all right. Okay. I knew that wasn't going to go down without a fight. There we go. All right. Now, let's see if we can... Okay, that's good. And hold that down. Alright, so that's a bit better than it was. I think that'll be okay. And then we have the new resistor installed. And replacement, I should say. And let's make sure it reads properly in circuit. And we get 1K, so that's correct. And alright, so if anything, you know, if this one burns up, we know that okay, that's secure, it's not lifted anymore. We know that there's something wrong, but there shouldn't be. You know, it comes off of this is the main B plus resistor here, and that's not corroded or burned up either. And again, the B plus test point's actually right there, TP202. I don't see any other heat related damaged areas, so maybe this resistor under load is failing, I don't know. But okay, I guess the next step is let's just test our HOT, make sure it's not shorted. And diode. And it's not, that's good. HOT is fine. Okay, let's test all of our traces on the vertical IC and make sure that nothing is open. Okay, let's go here. Good, good, good. Alright, alright. Okay. Alright. Good. Good. Okay, we don't have any open traces. Let's make sure we don't have any shorted that shouldn't be. If we go to ground, and there should only be, the only pin that should read to ground is pin 5. I think that's what that is. Yeah, so here's pin 1. Okay, this here is pin 1. Pin 5 should be ground. We should have no other pins read to ground. 1, 2, 3, 4. There's 5, 6, 7, 8, 9, 10. Okay, so the IC is not shorted. And again, the easiest way to actually test that is there's a diode in here, D603. There is a diode right there. And if it reads both directions, then the vertical IC is shorted. But if it reads only the correct direction, negative on cathode, positive on anode, you get 0.45 voltage drop. 0.54. Now if we swap our leads, it should have no reading. If we have the same reading, then the IC is shorted. Swap the leads and we don't have the same reading. So the IC is fine. So we double verified that. We're gonna have to see if we can replace this. We don't need to really replace it now. We can kind of just set it in place and glue it for now, but we do need to replace this. I'm not gonna send it back with a busted up coil like that. See if we can flatten this a bit more. There we go. So that's taken care of. Vertical IC checks okay. Let's test R303 because someone was chasing a vertical collapse problem. That's why they've changed 303 and the IC. R303 should read 1.2 ohms and it reads 1.3, close enough. That moved around a bit though. Seems alright, I guess. Well, okay, so I guess the next step is to fix this. And it's all twisted around on itself. Let's see if we can maneuver it to how it should be. This needs to go over there. And then we need to twist this around. This is all foobarred here. I'm not going to be able to get this to sit flat on this plastic because of how foobarred the coils are here. But yeah, I may just replace it. I've got, let's see here. Got some coils here. I don't know if I have the right one. Let's look at the part number. I've got this one and this one. I got a couple here. So this part number is 9 alpha 2970002. 9 alpha 2883005. Well, any of these will work, but they'll have the wrong inductance. So we might have linearity problems, and we may not be able to adjust the width completely, but any of them will work to make the circuit function. What is this one? Hey, look at that, 9 alpha 2970002, direct replacement right here. And it looks like it's already been previously glued. Yeah, it's broken. But for testing purposes, you can see here that it's broken also and it's been hot. See, I robbed these parts from other parts chassis, and it looks like somebody has glued this all back together. But I think since this is at least the same inductance and the same part number, we'll just put this one in here. We may have to just leave this in there because it's secure and you don't need to adjust it. You know, you don't adjust the horizontal width with this, you adjust the horizontal width with this. Right there, width. So all this is doing is just being used to complete the circuit. It's not actually changing the inductance by moving the coil in and out. It doesn't actually change the width, the pot does. So this is fine to actually just stay in there. It won't need to be adjusted. I'll probably have to just leave this one in there because I don't think you can order this one. I don't know if this is available anywhere. But since this one's more intact, we're going to probably just leave this one installed. So let's remove this one. And I'll keep this one and try and fix it later. And I'll just use this one to replace this one. So let's get that one out of here. I don't know what that's in there for. There's another leg here touching this thing. I don't know what that leg goes to. What does that go to? Well, that's for this capacitor across here. Huh. Alright. Well, I guess we'll reattach that. Not a big deal. Oop. Alright, let's grab this one. And this one. This one. And that should come right out of there. There you go. And if we look at the part numbers, 9 alpha 2970-002. So we can use this one as a replacement. The inductance is very important on these things. So you want to make sure you get that right. gotta straighten these legs out here. I might have to put a little bit more glue on this before I send it back because it is a bit wobbly still. But plus, you know, the problem is that this is going to get so hot, it's just going to melt this glue. So, I'm not sure what I should really do. I know I don't have any chassis that have these on them. And there's not really any way for me to really, I mean, I could rewind this. It's going to take a little bit of effort, but it's just going to end up like this other one. There, see? Now it sits flat on there, but there's no way to make it stay there. And even if you could, the heat is just going to annihilate it. I wonder if I could just throw a little glue in here. Alright, well, let me try that. I'm going to hold this for a while and see if I can make this work. If I can get this to stay and be more secure than this is, that heat's not going to loosen the super glue, so I probably might end up putting this back in if I can get this to be secure. So give me a few moments and see if I can make this stay like this. Okay, so I got the width coil drying. The glue is over here off camera with the fan blowing on it, drying in place. So we'll put this back in the bag and set this aside because within 5 minutes this will liquefy and just be right in the same position we are right now. So I didn't realize when I found this in the bag that it had already been previously repaired with hot glue. Now if this was a 7400 or something where the coil is over here, it wouldn't be a problem, but not on the 2000. Just isn't going to work that way. So we're going to put this back. I did notice something, is that on this one that I fixed in the previous video, you'll see that there is nothing here between the HOT and the H-coil. There's nothing there. But on this one, there's a capacitor here. Why is that there? I've never noticed that before. I didn't notice it until just now. And that is a difference. I checked this one previously in the previous video, and this doesn't get very hot. The heatsink doesn't get very hot, lukewarm at best. This one obviously has evidence and signs of being scorchingly hot, but this one has this capacitor here. So now I'm wondering if this capacitor may be associated with this extra heat from the heatsink. However, I've done this research in the past, and I've had one that gets hot and one that doesn't, and I went through every component and didn't notice this before. So I don't know if this is a special revision that has that cap. This is revision, that's very interesting. This is revision I, P717I, and somebody has penciled in or marked in an M. This one was also an I, and someone has marked in with a pen M. Now, is that because they've added this capacitor? I don't know. That's very interesting. What makes an M? Is it just that? I don't know. I don't know. We can do some experiments and see after we get this up and running. Verify that this is getting really hot. If it is, we can take that capacitor out and just see what it does. I mean, it shouldn't damage anything. We know that this can run without it because the I runs just fine. So that's very interesting. But while the coil is drying the glue, let's take this, let's just remove this flatback completely. And we're going to put this customer provided one in because they provided one. We might as well go ahead and use it. And we're going to take this one out and see if we can fix these pads, because we've got what looks like 1, 2, 3 lifted pads, and then possibly this one has a wire around it, so possibly a damaged pad on that one. The rest of these look okay. 1, 2, 3, 4, 5. Those are all 6. These 4 and these 2 are okay. But we got 1, 2, 3, 4 suspect pads. We know our power supply section is good, so let's get this flyback changed out. And I also need to push all these pads back down flat for the vertical IC that are lifted. And we don't really need to take this capacitor out. All we really need to do is just not solder it back in on here. If we look, it's going through a hole. It's going through a hole right there, and then it's touching that pad. So all we have to really do is not bend it over and solder it back in place. So let's get this. I'm gonna move this out of the way. Let's get this flyback out of here. I need to not lose this pad. Can I get this pad off of here? Yep, there it went. There it is. So let's save that. You don't want to lose that. I don't know if this got impacted or someone removed it and when they put it back in they did all this. I don't know. This is an odd one. But I think based on this, we'll get this flyback replaced, get the pads fixed up. We'll flatten out the pads for the vertical IC. We'll get this horizontal coil reinstalled, and then I think we'll just go ahead and fire it up and see if it works or what situation we're in at that point. I got to get this wire off of here. Get off of there, there we go. All right, that should be it. There we go. Out it comes, so we'll set that aside. And, okay. Well, so while that's out, let's go ahead and flatten these all down. Okay. All of these are lifted. Every one of them. Okay, so those are all down. Did we create any bridges? Let's take a look. Nope. Let's verify. Nope. 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 Okay. So we got that. We need to push that one down. Alright, so we got that out of the way. So let's look at things one more time here. Yep, not bad. Joints on the header pins are good for the video. For the AC look okay. Well, let's get this H coil reinstalled, and I'm gonna go ahead and hook up this leg to that pin just to see. Well, just because that's the way I guess it's supposed to be, and then if it gets super hot, we will remove that and see if that makes a difference, because that we may have stumbled onto the answer here, but we may not have also. So everything else seems okay. So let's see if our glue is dry on our coil yet. And it does appear it is. That is nice and secure. So we have repaired our coil, and the heat should not affect the cyanoacrylate. Let's flatten our pins out here a bit to make it easier to put this back in. I think that'll work, and like I say, the heat is not going to affect the super glue, so hopefully it should work. We need to put this in here like so. There it is. All right. And one of the legs is broken, so we're gonna have to put a jumper in there or figure out how we're gonna fix it. Alright, so this one we need to put in some type of component leg. I don't know. Let's use this. Will that fit through there? It will, but I don't know if we can make contact with it. Get some of this solder off of it. Hey, alright, so that fits through there. And on this side of the house, we're going to have to see if we can figure out how to hit that. So let's just solder this side in first. Sorry you can't see what I'm doing. I'll show it here in a moment. But the leg is broken off of the coil. So I want to add a little piece in there, and I'm using this leg from this resistor that we're going to solder in and then cut off. Like so. Now I need to bend this over. Okay, that's soldered back in, and I broke it. Awesome. Without the flyback installed, this thing is sitting against the test bench, and I just broke it again. Well, at least it's... I'll throw some more glue in there, because at least it's sitting there and not wobbling around. I just need to put a little bit more glue back in there. You know what I need to do is probably use some 2-part epoxy. I don't have any 2-part epoxy. What I'm going to do, I'm going to use some 2-part epoxy on this, but I don't have any at the moment. So I'm going to glue it back down with the super glue, or maybe just leave it the way that it is, and then I'll fix it off camera before I send it back to the owner with some 2-part epoxy. But now we need to get in here with our iron and put a little dab in here. Okay, now we can bend this back over. Okay. Now let's make sure that our coil is secure in circuit and we have a reading. We should be reading 0 ohms across the pads for, I believe, here and here. Okay, 0.7. So our coil is in circuit, so we're good there. And I think we'll just leave it the way that it is for now. Let's get our replacement flyback installed and let's turn it on. That's about all we can do. Put this right here. Set that aside. Actually, put that back over there. Alright, I'm going to save the box so I can put the original one in here. And as a matter of, yeah, we don't need any of that. I'll put the original one in here so the owner can have it back. And I'm also going to put in this resistor that is suspect. And then there was another component I thought. I don't have it over here. I don't know what happened to it. I thought there was another component that we took out. That one. Oh yeah, that resistor. I think I used the leg. I think I threw it away. Did I throw it away? Ah, dang it. Oh well. It was no good anyway. Alright, so we're going to put that resistor in here and then we'll send this back with to the owner so he can have all the parts that we don't and that we took off and don't need. Alright. So, let's get this flyback installed. Should go right in there. Should go, actually we need to clean out this hole here for the ground. There we go. Man, somebody has got these pins all out of whack. There we go. Okay. We are sitting flat. And let's solder this puppy in. Sometimes these have a coating on the pins. You need to kind of scrape away with the tip of your iron. I thought I needed to do the other one, but it turns out I was wrong. It just wasn't aligned properly. And I was referring to this here. I opened up this hole. I thought that I needed to, but I ended up not needing to. So not that it matters, but there we go. Hold that one down. That one actually kind of settled down on its own. Alright, now let's fix this one. And let's grab the pad that I set aside. If I can. Why are you being difficult? There we go. Get you on there. Spin you around. Let's solder it in place. There we go. Let's scrape it away. And let's jumper it. There you go, boys and girls, just that easy. All right, well, is that it? I think that's gonna do it for what we need to initially do. Yeah. I think that'll just about do it. I think that might actually be fine the way that it is, but we'll secure it with some two-part epoxy so it shouldn't ever break again. But for now, let's get our neck board reinstalled. Neck board, I don't think the neck board actually needs any work, but since I have to reflow it anyway, well, I mean, I don't think it needs any work before we turn it on and test it. Since I have to take it apart anyway, let's yeah, not too bad. Awful thin. Very little lifting. Not too bad. So, okay, we're fine there. So let's just get this hooked back up. Let's hook up our focus wire. The focus wire is always, you know, the colors may not match the old flyback versus the new flyback, but the thick wire is always focus. The skinny wire is always the G2. So if we take our focus wire, somebody has kindly soldered this with the wires being frayed out, and it doesn't want to go in the socket. Maybe that'll work. Yep, got that in there. Okay, so that's in there. Spin that and poke that on there. Our G2 wire, we can just get rid of this pin and solder it directly into the hole. Really? This glue is keeping the whole pin in there, the whole base, I mean. There we go. Okay, so we got that out. And then we can just take the wire and just solder it right into the hole. Like so. Okay, so that's our neck board reinstalled. Let's hook up our remote board. Solder joints on that look okay. Yep, alright. Well, here it is. Let's actually hook it up to a tube and turn it on and see what kind of fiasco we get here. Hopefully it works, and if it does, we'll just do the cap kit, the reflow, and call it a success. And I still have to fix that again, which I've mentioned about 1,000 times now, but anyway. Yep. Alright, so let's get it turned on and see if we're any better or worse, or... Well, I guess we never tested it originally, but I mean, what do I mean? See if we're any better off than we were before we did any work, because we obviously know it wasn't working with the flatback joints cracked and broken like that. So let's see where we're at. It's probably the best way to say that. So, okay, I'll grab a tube, hook it up, we'll turn it on, see what happens. Okay, well, here we go. Got everything hooked up. Anode, neck, yoke, ground, power, video, remote. We're set up to read our B+ on our test point that I showed earlier, assuming it does turn on. And if it does, and hopefully it's around 117. If it's not, I'm not going to be able to adjust that pot because it's coated pretty well in the glue. But it should be somewhere close to 117 based off what it visually looks like it's set to. And I have actual JAMA harness here for my MK board. So we'll see how this turns out here. Hopefully it turns on and works, but only one way to find out. 1, 2, 3. No. Started to make a squealing noise. Let's look at B+ here. Let's try again. 1, 2, 3. 145. So there's something wrong on the output side of the B+. There's no load on the system. Why would that be? Let's try again. 1, 2, 3. So the power supply just clicked on and it's working. But it's not, there's no load on it. It's stuck at 146 volts. It should be 117. There's no load on the output. I wonder if there's a bad solder joint somewhere. I'm going to push on various things here. No, it's dead. Totally and completely dead chassis with a known good power supply. Could very well be U701, but someone's changed it out already. Could be Q703. Could be R765, R760. HOT could be bad under load, even though it tested okay. Could be any number of things. We know it's not the flatback. Changed that out already. There could be a crack in the board somewhere else. But we've got a working power supply, but there's no output. The load is like the B+ resistor is removed. If we were to grab our light bulb, I don't know if I could do this with one hand here, but if we were to remove this here from our lead and just go right to our frame and touch the light bulb. Yes, I don't know if you can't see here, sorry, I'll switch it around here. We have, let's try this way. There you go, yep, see? And our B+ dips down to, oh, I can't tell because I don't have it hooked up. But anyway, so our power supply is working, but the output is not. It's like there's something on the chassis that has either the B+ resistor is bad, or there's another cracked joint somewhere. There's something on the output side that's not getting energized, and got to figure out what it is, whether it's a bad cap or a broken trace or a bad component. I don't know. Have to dig through here and see what we can find. All right, so I think I found the problem, or at least a contributing factor. Q703 is faulty. So Q703, like I mentioned, if Q703 is bad, it will not power up. So using the known good one that we fixed in the previous video, we're going to use some compare and contrast here. Now, if we go, the way you read this is, let's zoom in here. So you'll notice here that if we get this in here. All right, so Q703, the positive goes on the inboard lead, and then to each other leg you should have 0.6 voltage drop. So to the middle leg and the out leg should be 0.6 voltage drop. So from the outside with the red to the middle, 0.6 voltage drop. Outside leg, 0.6 voltage drop. Now if we swap this out with our non-working one, and we do the same thing, we go to red lead outboard, black lead on the middle, and we don't get our 0.6 voltage drop. Go to the outside one, it's 0.5. So, see, there's the middle, and there's the outboard one. So we have a bad Q703. So we need to replace that puppy. And I don't think that any of those were included in the parts. Let's take a look here. Nope, those are just leftover caps, and there's no Q703 in here. We got a 701, a B plus pot, a 702, and some FJLs. Nope. Fortunately, I have a bin of parts, which we've already shown basically, and I've got this Q703s right here. And if we take this out of here, I have 3 of them. So let's grab one and put this back in here. Put this away. Let's take this one out. Clean up the pads. Okay, turn my fan back on. Let's grab our replacement and put it in. There we go. Stay there, you. Let's solder this one in. Okay. Go back over our joints. And no bridges. Okay, now let's try again. Red lead on the inboard. And 0.6 to each leg. 0.56 and 0.59. It's still hot. See, it's climbing 0.6. Well, 1, 2, 3, 4, 5, 6. Middle one back 8, 2, 3, 4, 5. So there you go. Most likely this was our problem. So let's get it back on the tube and try again. Alright, we're all hooked back up with the new Q703 installed. So let's see if we now have power. I don't know if Q703 was the entire cause of the problem. It could have been a contributing factor. So let's find out. We've got B plus set up again, ready to read if it does turn on. So here we go. 1, 2, 3. Well, look at that. It turns on. B plus is, holy cow, 126. That's way off. But is our victory short-lived? Or is our victory... It doesn't sound good. It sounds all like it's out of... Oh, I forgot to turn up the flyback. Contrast down, brightness down. Let's turn up our flyback. Let's turn up the flyback here. And okay, we're not collapsed. Let's do our focus. H hold. Boom! Ha ha! Well, let's gotta turn our screen pot back down because it's too bright. Right about there. Contrast. Too much. Brightness. Whoa. Huh. That's still too high. Back down. Let's go right there. Brightness needs to stay right there. Contrast. Brightness back down. Oh, this stupid board. Okay, well, let's swap this out for Rampage World Tour or something, because let me set my 3 pods down. And let's swap this out for Rampage World Tour, because this darn MK board just doesn't like to play sometimes. Of course, I could be using the test pattern generator, but I don't want to use that. Let's try again. Comes right to life. 126 though. We're going to have to actually adjust that. But yeah, so let's do brightness right there. Contrast. Yeah, let's do contrast up and then adjust some focus. We got color bleeding problems. This thing needs caps out the wazoo. Let's see if we can get better focus here. Ah, crisp. There we go. Well, yeah, we got some type of bleeding shadows and stuff. If I turn the contrast down, it doesn't go away. Brightness, okay, brightness makes it go away. Yeah, that's not bad. But we need, it's too red and, okay, vertical size. Vertical size, so we don't have collapse, that's good. But yeah, see how it's bleeding here? If I turn the brightness down, no, it doesn't go away. Contrast doesn't go away. So we got this bleeding thing going on here. See that? Let's just go into the menu here. Yeah, there's this. So there's this bleeding off to the side here. If I turn contrast down, it's still there. Brightness down, it's still there. So we need to do a full reflow and caps and get this thing all fixed up and see if that issue goes away and what's going on there. So we'll do that. So I'm going to cut away, take this back off, do all the full reflow, the full cap kit, neck board rework, everything I normally do. We'll come back and see if this issue still persists. I'll leave everything set just the way that it is right now. And we'll go back into the menu here and see if this is still there. And I'm curious how hot this heatsink is. Oh, not bad. That's even better than the other one. That's not even lukewarm. That's like room temperature. Huh. Well, why did this thing get baked if this doesn't even get hot? That's another mystery. These U2000s are just such a mystery. It's unbelievable. If you have a U2000 out there, run it for 10 minutes and go see if this thing is boiling hot. You know, it's because it's hit or some of them do, some of them don't. That's just very odd. I'm curious as to why this thing baked if this is fine. Interesting. Well, okay. Yeah, let's get all the rework done and come back and see if this is any better. Well, full rework is now done. All the caps, all the reflow, neckboard rework, everything is good to go. So a brief recap before we start, no pun intended recap, ha ha ha. We changed out the out of tolerance R104, we changed out the possibly faulty R728, we had the bad Q703, we had numerous cracked, broken, and bad solder joints and lifted pads, took care of all that. I think that might have been it. We had the broken width coil. I got that glued back in place, was nice and secure. Now, I'm not sure I'm going to end up needing to use the two-part epoxy because I threw a bunch more glue in there while I was doing the cap kit, and it's nice and solid now. So I don't want to break it, so I'm not going to move it around too much. But you can. It's good to go now. So I think it's probably going to be okay. I did want to mention that the blue bias pot had been already replaced by the previous person or whoever tried to work on this in the past. But I think that's it. Oh, I did find one problem. C712 right here, it had a 50 volt 220 microfarad. Well, it's supposed to be 16 volt 1000. So someone had a 220 volt microfarad cap in place of where a 1000 microfarad cap was supposed to be. So that might have been part of the cause of our shadows on our text and our colors and stuff. That might have been part of the problem. So that was an incorrect cap that was installed there. Everything else was correct. But I got all the rework done. I need to go through and clean it up still, but I got reflow on the vertical IC. I got all the caps changed out, of course. We got any solder joints that were even close to needing reflowed have been reflowed. Yeah, pretty much all the work is done. We saw the work on the flyback. Again, I need to clean this up. I always clean this up as the last thing that I do before I box it back up. So don't worry, this does all get cleaned up. I don't send these back and covered in flux like this, so don't worry about that. But it is now ready to test one last time, and if we're all good and everything works perfectly after we get some adjustments made, then really the only thing wrong with this was an incorrect cap and possibly other bad caps, possibly R728, definitely R104, and a definitely bad Q703. So let's get it back on the tube and turn it on and see if it's any better. Okay, I'll hook it back up, ready to go. I have the meter set back up to read our B+, and I was able to successfully egress the glue off of the pot, and I was able to move it. I put it back where it was, so it still should be 126 around there, and we'll adjust it as needed. The easiest way to do that is to get some very sharp diagonal cutters and just kind of very gently try and crack that glue off. If you're too rough with it, you can actually break the top of the pot off or break the pot itself. Then it's game over. You got to replace the pot. But I was able to successfully remove that glue off of that pot. So now we can adjust it, and everything is set exactly as it was when we last turned this on. We'll go into the menu, make sure that bleeding or the ghosting or shadow is gone. I'm confident that it will be, especially with that incorrect capacitor installed and the reflow and new caps and everything, including neckboard rework and stuff. So I'm confident that we should be good now. We'll find out here shortly. But we're all set up to go. I have Rampage World Tour hooked up again, so let's turn this on and see what our B+ is at and adjust it down as necessary, and hopefully our ghosting is gone. Let's find out. 1, 2, 3. Okay, it comes back to life. And let's make sure it's actually working still. Yes, it is. And so far, so good. Holy crap, 128. Let's see if I can... let's turn this down. I can't reach in there while power is on because I don't want to touch that test point or anything else. So I'm going to turn this to where you can see where it's set at right now. I'm going to adjust it to where it's set to the middle, because as you turn it to the left, it gets higher. I'm going to put it roughly in the middle there. Okay, so right there, I have moved it to roughly the middle. Let's see what that reads. 1, 2, 3. 122. Okay. I'm going to go even lower, I guess, here. So let's put it right there. And that's where it's at right now, a little bit lower, so let's see what happens. 119, getting closer. I don't know how it could be so far off. I mean, it was still factory sealed. I don't know how it could be so far off from there, but okay, a little more. There we go. So now it's sitting right there. Vastly different from where it was. 117. Happy with that. Okay, now let's see if we can get this to look good. There we go. Okay, a bit dark, but that's fine. We're a bit too green. That's okay. And we're shifted too far that way. That's fine. Okay, let's start over again. Let's go. Actually, you know what? Before I do anything, let's go into the menu and make sure our ghosting is gone here. Yep, good to go. We can see that our problem before is now gone. Absolutely, we had incorrect and or bad caps. So most likely that cap that was supposed to be 16-1000, that was 50 volt 220. Somebody was a knucklehead and put the wrong cap in there, but we got all of our colors. That's good. We can go down here to test monitor pass. So we got red, green, blue. Okay, let's adjust You know what we need to do? Let's go down here to this. Okay. All right. H position. We'll go right there. Vertical position is good. Okay, there. Height. That's fine. Okay, there's our position. Does our width work? Don't think we tested that. Yep. Width works fine. We'll leave it right there. Okay, let's escape out of here. B plus is, it's at 118.0, 117.6. So as things change on the screen, it changes, but we're 117.6 right now. Look how green we are. Man. Let's turn, oh, we're too bright also. So let's try this again. Brightness down, contrast down. Okay, flyback is okay being right there. Let's turn up contrast and brightness. I need to move our screen again here. H position, roughly there. Let's lower our width slightly and vertical size slightly. Okay, I think that'll be good. All right, now let's turn our red up slightly and our blue up slightly. And that's looking better. Brightness is a little bit too high. Roughly there. Red up more, blue up more, a little too much blue. Well, there you go, not too bad. Could be better, but not staying on this tube, so it's no big deal. Let's try a little bit more contrast. Ah, there we go. A little bit more contrast, a little less brightness, and a little less red. There we go. That looks good. Okay, in person, it's much better. I don't know if it's the viewfinder, looking through the viewfinder that really changes, opinion of how this looks, but in person it looks fantastic. Reds are good, greens are good, blues are good, but looking through the viewfinder, I don't know, maybe they'll look better on the video once the video's uploaded, but yeah, I think we're good to go. I'll let this run. All the work is now complete. We'll give it its normal burn in. We're still at 117.6. It just changed 117.4, so B plus is perfect. I don't know why I had to turn it so much from the factory setting, but that's odd. But hey, we had we had R104 was out of tolerance. We've already gone over it, but 728 was kind of burned up. Q703 was bad. We had multiple cracked and bad solder joints and pads. And I'm probably forgetting a bunch of other stuff. Oh, we had a bunch of lifted pads. We had the incorrect capacitor installed in the wrong location. After getting all that fixed, it appears to be good and working and should last a long while. I'm moving the harness around here, but I want to, come on. There we go. I want to see how hot this heatsink is. Yeah, it's barely even warm. I'm mystified as to why that width coil burned up like that. It was obviously heat discolored and everything, but it may have just been because one of the other components started failing and it got hotter and hotter and hotter and then failed. I can't say. But right now the heat sink is barely even past room temperature. I just don't have an answer. Maybe it's that one capacitor. I took note of it. That capacitor, that mystery capacitor off of that coil is a 1.6 kilovolt 220G. So I'm going to do some research and see if maybe grab a U2000 that's getting extremely hot, install a capacitor like that the way this one's installed, and see if that brings that temperature down of that heatsink. If that works, then we've performed a miracle and we can save a bunch of U2000s that are getting too hot. So, but otherwise, yeah, this appears to be good to go. I'll give it normal burn-in time and Send it back to the owner, and we are successful. 2 for 2 on the U2000s for the same person. So thanks for watching. Hopefully you learned something. Like, share, and subscribe, and I will see you next time.